Hello, everybody, and thank you for having the opportunity to present some basically ongoing or just started work together with the Ritter Group. So Ritter Group means not the chocolate part, but the probably, well, I wouldn't say anything about it, but it's the energy group, and it's all related. It's the same family, so there is a connection, but the talk today will exclusively be about energy. Sorry. But before I go into any details about the Ritter Group and the work we do, I would like to use the opportunity to give you a very brief introduction of my company, P International. Then I will give you a brief overview about the entire idea of the Ritter project and a little bit about the time frame. And then I will basically come into the core part of my presentation. This is the issue about energy relevance for carbon footprinting of different energy carriers within a life cycle assessment or value chain of a product. And I know that some things I will present here today are discussed differently, and there's some criticism to the concept of balance. I'm very open to discuss that issue later. Maybe also not in that context here, but even later in today, because we are very keen, me or P International and Ritter Group, to get some opinions and some criticism from you. So, P International, I think most of you probably heard about this company. P International is basically about people. That means we are a consulting company. I myself feel and prefer to be a consultant. I don't prefer to be data or software, but we also have a huge database, which is pretty much known as the Gabi database, and we also having two software products, which you can see on the next slide. It's the Gabi software and the Sophie software, one focusing on product or life cycle assessment and the other more on the enterprise level. But there are nowadays different interfaces available, and there's also possibilities to work together with SAP softwares. We are a global company. I don't want to get in any details. I'm proud that I finally managed to have an office in Berlin, so I don't have to be in Stuttgart that often anymore, where our headquarters are. And as you can see on the map, we are having offices all over the world. We work with loads of different companies, and I'm very proud to show this to you. This was a kind of investigation, and what you can see that out of the 10 most successful, or whatever you want to call them, brands in terms of sustainability, 9 are our clients. And as you see on the reference list, we do carbon footprinting for almost everything and anything you can think of. Now, that was PE, and the talk today is about Ritter, so I come to the company we actually did the work for. So Ritter is a small and medium-sized company, about 1,600 employees. They're located close to PE in Dettenhausen. That's in Stuttgart area. That's where the headquarters are, but they have offices and they have production sites all over the world, in particular in China, and that's a particular focus of the presentation today. The product portfolio, and this is also an important part to understand the work we're doing and the entire concept of the carbon balance of Ritter. It's mainly solar systems they produce, and they produce large-scale solar systems and solar systems that directly go to private housings. And this is the focus of the presentation and also the focus of the carbon balance we look at. But additionally, they also produce heating systems for conventional gas energy carriers, but also wood pellets. Oh, I'm going the wrong way. Are we on the right one? No. Here we go. So the concept of the carbon balance, and the carbon balance is not something we invented. It has been, well, become popular by the chemical industry a couple of years ago, and there has been a lot of criticism. As I said before, we're aware about that, and I think we have good answers to all the criticism, and we're happy to discuss that later. So what I want to do now is give you, for those who doesn't know the concept, a brief introduction to the concept. So the idea, or let's start with the concept. So the concept of the carbon balance is that you have two sides. First, you have releases of greenhouse gas emissions when you do the actual production of a certain product. In this case, the production of a thermal collector, solar collector. And this is where you have basically your emissions. And on the other hand, and that's why actually Ritter is doing what they're doing, because they've founded this company for the only purpose to do something in the energy sector. So there used to be that chocolate company, and then they had an idea during the Chernobyl crisis, we as an enterprise, we have to do something. So that's basically the business model behind Ritter Energy Group, is to start mitigation or to do something for renewable energy. So, and then the idea is you do a product that is basically built to save, or to save energy, or to kind of produce energy with less carbon intensity. So that's basically the idea, and that is where the savings come from. So what you need when you look at savings, you need to have a reference system. I will come to this later. So, and then the idea, the first idea of Ritter is having that system of a carbon balance is to have a kind of guidance to all the activities they have, because they want to reduce carbon emissions first by reducing the greenhouse gas emission in the entire production chain, and also by increasing the efficiency of their products. So actually, you have two different paths of actions where you can improve the carbon footprint. So as I said before, we just started the project, so we are in a preliminary project phase. The concept of the carbon balance is not finished yet, so we're still working on it. And once we have done that, and hopefully we'll get some input from you, we will start an implementation with some clients or customers here in Germany, and then we think about having a real establishment on the market. So the milestones of the preliminary project are basically doing a product carbon footprinting, first doing a pilot on one selected Ritter solar collector and a reference system. So this is basically the content of the talk today. And then after that, and we're just in the process of doing that, doing a rollout on the entire solar collector portfolio. And then also taking into account other Ritter EcoQuence products. This is another concept I can't just explain to you today, but I'm happy if you need further information to talk about it later. And we're also currently doing a corporate carbon footprinting. So coming back to the product carbon footprinting, there's some information here, and the most important message here is whatever we do, we always try to be in line with existing standards. So we do the product carbon footprint calculation using the greenhouse gas protocol standards. We also do the comparison with the reference system being in line with the ISO standards 14044. So, and we also make some, or usually you have to do a lot of assumptions, and whenever we do assumptions, we try to use a standard that is already established to justify the assumptions we make. So we don't want to come up with some things that might give a benefits from us by just choosing some lovely assumptions. So what we're talking about, as I said before, evacuated tube collector system, and this is basically what is called a process map. We don't go into detail here, but what you see is the usual life cycle, and I think everybody's familiar with that. You have the production, you have the raw materials on the left-hand side, then you have the final manufacturing in Dettenhausen, then you have transportation to the final client. And then you also have the end-of-life phase. So what is the focus of the talk today is basically the cradle-to-gate analysis. That's a raw material and manufacturing bit. And what you can see here, we basically have four supply routes which play a role, which we are currently looking at. It's the aluminum profiles and sheet, is the plastic-based intermediates, and we also have the vacuum glass tube production, and then we also look at the steel components. So the overall carbon footprint, that's the only absolute figures you will get today. It's 237 kilograms per functional unit. And there's something I need to say here, because we're going very deep into in our analysis, and I show you some things which are usually not meant to be shown to public, so I won't give you any more absolute figures here. I hope you understand that, because what I'm doing is very sensitive in terms of production data. So when we started the analysis, we basically wanted to know what is that all about? Where does the carbon footprint come from? What is the role of energy? And then we just did basically a primary energy analysis. And the first finding was about 90% of the energy used over the entire product life cycle is covered by non-renewable energies. And when you look, we also had a breakdown by energy carrier. It's mainly hard coal. This comes from the different grid mixes we have in the production. And then we have natural gas. This is basically used for thermal energy. And having 90% of non-renewables, that means that theoretical is a very high potential to reduce the carbon footprint. And having done that, we try we just do that. We look at the different supply chains, and we go really into detail and try to understand what kind of energy is used in the different production processes. And we're doing that using our software, which basically is built up on different layers, so we can go deeper and deeper and deeper, and I will demonstrate that while doing that analysis for the tube manufacturing. The manufacturing actually takes place in China, and what you see here is the percentage figures give you the contribution of each process, either energy or product material going into the production, to the carbon footprint, to the CO2 footprint. So 32% on the left-hand side, this is the contribution of the electricity consumption to the entire process, the CO2 contribution. And because we're in China with the production, we can see that 85% of the carbon footprint, that is on the left-hand side, the gray bar, is caused because of the use of hard coal in the grid mix in China. So on the right-hand side, you can see the thermal energy. There we have basically just natural gas. So 100% of the thermal energy is generated by natural gas. So what we can see is that energy really already contributes to 60% of the total carbon footprint of this production of the vacuum tube. So the remaining 40% are embedded in the input materials. But before we go to the input materials, we also, why we're doing that analysis, because we try to find out where we can improve. Because Ritter has a joint venture there in China, and they're really keen on finding ways to improve, to reduce the carbon footprint. So when we look at the thermal processes, because we're dealing with glass processing, that's a temperature thing. At the moment, natural gas seems to be the best option available. If you compare it to light fuel oil, heavy fuel oil, or hard coal, it definitely performs better. So there's already, we are on a good way, I think. But when we talk about, or when we look at the electricity, there might be some options, and we heard about these options all day. So one option we're thinking about is the on-site energy production. Might be with the cogeneration, but as you all know, we just can't go there. Oh, this isn't quite a good idea. Just do it. So it takes some investment, and it needs also some rethinking. And there's also the issue of green power purchasing, but being in China, that's not on the agenda today. And also we heard about all the problems with the accountability and so on and so forth. But we are keeping an eye on this issue, and one reason why I'm here is to learn about these green power purchasing. And in particular, I mean, because we are dealing with the Chinese mix, and the German mix is not much better than the Chinese mix, there's a huge reduction potential. Even if you go from the electricity mix to a combined heat and power plant, you will have a reduction of about 50%. So coming back to the initial slide of the analysis, so what you see here, we have 60% of the carbon footprint because of the energy production, the energy used on site, not the production, the energy used on site. But there's also 40% of the carbon footprint embedded in the materials or the intermediate products going into the production. And what we did is then really going deeper and deeper and deeper and see what is behind that. Where does the carbon footprint come from? And when you go on the next deeper level, we have the silica sand or the quartz sand here. And what you can see, it's basically about 90% is coming from energy again. And I don't want to go into details. This is another issue we face here, an issue we talked about not that much today, but it's also a big issue, the issue of secondary data and having primary data. So what we did here, using a proxy from our databases, because there was no supplier data available and there might not be primary data available. We're currently looking for, or we setting up a list where to go for data from suppliers. Is it possible to get some data? Is there just one supplier, so on and so forth? So we want to learn more about where does the carbon footprint come from, and what we can see from this initial analysis using proxy data, it comes from energy usage. And we even digged a little bit more and more and more and more. So actually what all these kind of slides tell you, and now we look for borax, for the production of this product, it all comes from the energy. So looking at the energy, looking for options to substitute existing energy carriers with renewable energy carriers could be, or probably is the way to reduce the carbon footprint of this solar collector significantly. The question still remains, how much can a small company do? They can think about doing something on their own production side, or the production side they have a joint venture, but they also can think about choosing the right supplier, but there's some limitations to that. And we also looked at the potential of materials, or looking at what is the influence if we have different suppliers for certain materials. Aluminium is usually known as one of the worst materials in terms of carbon footprint. As you can see here, we did a comparison. On the left-hand side, you see the aluminium mix, which is suggested by the European Association, and it's about 10 kilograms CO2 per kilogram aluminium. And this is an energy mix behind that reflects the European energy mix. If we would have one supplier who could prove that they exclusively use hydropower for the production of aluminium, then we would have a reduction in the footprint of about 50% to 5 kilograms. But then again, and Ritter is actually using a supplier claiming to use hydropower, but then again, me being an LCA guy for many years, and double counting was always important for me, and so on and so forth. Can I use it or can't I use it? It's really the question, and that's something I think we haven't found a solution today. What I think, well, my personal opinion is we should be able to use that one if we really can prove it. But for doing that carbon balance, it's important for us to be on the safe side, because we don't buy cheap CO2 reduction. Ritter really wants to do something, and not just like labeling something that they haven't done. So this is an important question for us in the carbon footprint. And from the difference, you can see this will have a huge impact on the entire carbon footprint here. So it really matters in that product. So coming to the conclusions, what I've shown here was just a part of a huge project. We just started with Ritter, and we might come to the chocolate later in that project. So, but the idea is here really that Ritter wants to improve the production, and they want to improve the efficiency of their products. So they want to use both possible means of action they have. And I think that that's the idea of using a carbon balance, because you can show that. And the study I just presented here was focusing on the upstream value chain, and the finding here was, and that's not a big surprise, but it was a proof, it's basically the carbon footprint is dominated by heat and electricity. That is not really a new thing, or that's something you would expect. I mean, we are not having cows involved, so we don't have fertilizers involved, so that's just another proof for it. And what we also have seen is a high, and I point this out, the theoretical reduction potential. And this is, we have almost 90% that comes from non-renewable energy sources. That means we have that huge reduction potential. Now it's important, not just for Ritter, but it also demonstrates what we heard before. We can significantly reduce carbon footprints still. And we are just in a process to think about how we can reduce the carbon footprint. So what we have seen, what I've demonstrated, the vacuum tube production, there's a considerable reduction potential, in particular because we have the Chinese grid mix here, which is dominated by hard coal. So what we are investigating as options in the midterm is on-site energy generation. Yes, thanks, 1 minute. Basically, maybe just starting with gas, that gives us the opportunity to use biomethane in the future, but there might be other options. We also very keen on getting a better understanding how to deal with the issue of green power purchase, not just in Germany, but globally, because that's the issue, because what I know so far, we have a lot of concepts in different countries and different regions, but I think when we talk about harmonization, this is more important than having harmonizations in PCR, I think. But that's my personal opinion. What we also have seen, and this is just emphasizing what I said before, in the aluminium case, there's loads of potential, but we have to be sure that we're doing the right thing in the accounting here and not just do greenwashing, because that's something we definitely want to avoid. For heat, the perspectives are not as good, because we need that high temperature, and we can't use our own solar systems for having a glass processing, that's for sure. So, thank you very much, and I'm really looking forward for your feedback, and in particular also if you want to have 5 minutes to talk about the carbon balance concept, because I'm very keen on that too.